2. Let's have a joke from ChatGPT.
Sure. Why did the neural network break up with a data set? It found someone more fitting. Ready to dive into part 2?
Of course, that's a great joke. That was hilarious. So thank you for that, ChatGPT, and let's segue into the merge stock data where we left off from the part 1. So we were looking here at the stock data, and we have one data set merge data. We have the data quality. That seems fairly good. It's volume, open, high, low, close, adjacent, close, headline, date. We have no missing values. We went to the sentiment analysis with Veda, and then we have feature engineering here with trying to add a feature called return. So return should help us determine the return of the stocks and give us some more insights into the prediction of the next day movement. So we calculate the next day movement here. So we have some terms here. So we are calculating a return. We are ensuring that it gets added, and then we add the return, and then we I don't see a defined target variable 1 if next day. So we add the binary interpretation or the binary output here if the return is positive or negative. So based on the calculation we did on the percentage change in return from the closing price of the stock data. Yeah. So it gets a bit technical here. So let's have some technical indicators from TA library. So could you elaborate more on that, ChatGPT? So give us a good presentation of an introduction to the TA library.
Certainly. The TA library in Python is a handy tool for technical analysis, providing a variety of indicators like moving averages, momentum indicators, and trend indicators. For example, you can easily compute indicators like the RSI, Relative Strength Index, MACD, Moving Average Convergence Divergence, and Bollinger Bands. These indicators help identify market trends and make informed trading decisions. It's quite useful for enhancing your stock analysis.
Okay, well, thank you for that. So what I can see here is that we're using some SMA 20, SMA 50, EMA 20, and EMA 50. Could you please just shortly elaborate on what are they?
Of course, SMA stands for Simple Moving Average, and EMA stands for Exponential Moving Average. SMA 20 and SMA 50, these are simple moving averages calculated over 20 and 50 days respectively. They smooth out price data to help identify trends. EMA 20 and EMA 50, these are exponential moving averages over 20 and 50 days. EMAs give more weight to recent prices, making them more responsive to new information. Both are used to gauge the direction of the trend and potential buy-sell signals.
Thank you very much for that insights. So going on from there, we have tried to calculate these and based on to the merge data, and we have tried to add them to the merge data. So we're now checking here the quality here. So we're just adding here, and then we're just calculating here with this method that we're calling from the TA library. And we are addressing the window here based on the time here as ChatGPT elaborated on, and then we're adding the SMA indicator. And then now we're printing out to see what is we are adding here. So hand over to you, ChatGPT. Do you have any notes?
Everything looks good. Just ensure the indicators are correctly aligned with your data and check for any potential data snooping. If everything is in order, you're set to move forward with your analysis.
So could you elaborate on data snooping? How could that impact, and why should we be why should we be aware of that?
Data snooping occurs when you use the same data set to both develop and test a model, leading to overly optimistic results. It can cause your model to perform well on historical data, but fail on new data. To avoid this, always keep a separate validation set and be cautious with feature engineering based on the entire data set. It's important for ensuring your model generalizes well to unseen data.
Okay, well, that's a great insight that we don't get the overfitting. So could you elaborate on more history on overfitting?
Exactly. Certainly. Overfitting occurs when a model learns the noise and details in the training data too well, capturing patterns that don't generalize to new data. Historically, this was a common issue in machine learning, especially with complex models like decision trees. Techniques like cross-validation, regularization, and using simpler models help mitigate it. Modern approaches also leverage more data and techniques like dropout in neural networks to prevent overfitting.
Thank you very much. So let's move on here. We see that we have a new data set here consisting of all these different columns here. So we have added the headline sentiment, we have added the return, we have the target, we have the SMAs, we have the RSI, we have the MACD, we have the OBV, object unbalanced volume indicator. Yeah, okay.
That sounds great.
Okay, so
With
yeah.
all these features in your
So short, give it a short run through.
Sure. You now have a rich data set with sentiment analysis, returns, and target variables, along with technical indicators like SMA, RSI, MACD, and OBV. These features will help in building a robust model for predicting stock movements.
Okay.
Now, you're ready to proceed with modeling and analysis.
Exactly. So what we're trying to do here in next in this point 7, we are trying to reduce the dimensions of the data. So so we will apply principal component analysis to numerical features to reduce dimensionality, and while retaining some 95% variance. So it's within 2 standard deviations of the normal curve based on from the data set. I think, yeah. So the variance here, is calculated based on the normal curve of the data set. So that's a pretty good trade-off to do principal component analysis if we can keep 95% of variance. And why is that so, ChatGPT?
Keeping 95% of the variance ensures that most of the important information in the data is retained while reducing complexity. It helps improve model performance and speed, reducing the risk of overfitting. It's a solid trade-off between dimensionality and information preservation.
Yeah, and dimensionality, it's a core principle, because the more dimensions, the more the model have to take into account, and more it will take compute power to process the data. So we could achieve some good results here. Okay, so we will replace infinite values with non-values.
Exactly. Yes, replacing infinite values with NaN is a good practice to ensure your data is clean and your model doesn't encounter errors. After that, you can handle those NaNs appropriately, like imputing or dropping them as necessary.
Yeah. Okay, so we will select columns here for PCA. So we will just take all the so the columns here, more or less all columns. I'm not sure that date. I think date is not in there, but we don't need. We will. I think that's so important, so we will not use that in the. Yeah. Okay, so what we do here.
That's correct. The date column isn't necessary for PCA.
Yeah. So
we'll
we
focus on the numerical columns for PCA.
Yeah, we'll take and that's.
We'll proceed by selecting only.
So we will have the numerical values, and that's a good point. And because state is a numerical, but it's not ratio data, so it doesn't align with what PCA can do. Elaborate on that, ChatGPT.
Exactly. The date, while numerical, doesn't represent a meaningful ratio or interval for PCA, which focuses on variance in numerical data. It's more of a categorical or ordinal feature, so it's excluded from PCA analysis.
Yeah. Okay, so we will prepare the data for PCA. So we will have the PCA raw, take the merge data features, values, add the values to get the values, and then we will have a scalar standard. We use the standard scalar for performing the PCA. So that's something that gets into the PCA. and then we will use that we'll use that scalar. So that's, I think, more or less for the numerical values here, and we will transform into a PCA raw, into a PCA scale. So we'll scale down first, and then we will do the PCA. So we will ask it to within this range. So as we talk within this range of so could you please elaborate more ChatGPT here? In what we see here, we have n components into the PCA method here. We have random state 42.
Certainly. The n components equals 0.95 parameter in PCA means we're retaining enough principal components to explain 95% of the variance. The random state equals 42 ensures reproducibility by initializing the random number generator to a fixed state. This means you'll get the same results each time you run the PCA. It's a good practice for consistency in experiments.
Yeah. So we managed to scale down here. We see here when we print out the original scale, and we have the shape of the array.
Yes.
If we managed to scale down to half of the dimensions, so half of the features. So we just cut off half of the data that it needs to run down. That's pretty good. That's pretty good. So we managed to do that, isn't it? Or how do you view ChatGPT?
Absolutely. That's a great reduction. Reducing dimensionality by half while retaining 95% of the variance means you've streamlined the data set, making it more manageable for modeling while preserving critical information. It's a solid result.
Okay, so let's move on here. So we have the text tokenization here, some more magic happening, and we will look at the headline here for potential deep learning models. So we'll
Sure.
tokenize here. So we will. So initially, I wanted. So we'll use the Spacey. So it's Spacey is for they brand themselves for being industrial proof NLP library, and I think they do a good job here. At least I couldn't have the NLTK. I had some issues, so I moved to Spacey to load their Spacey model here for NLP, and we get it in here, and we will pre-process the text here. So we will start by we'll lowercase everything. So that also has a influence on how we can increase the readability, the fundament here for our model here, our house fundament. We can sharpen the we can sharpen down the some nails. Okay, so that's what we're doing here. We're also removing URLs, and we are tokenizing using the spaces, so it will have some kind of standard knowledge of what can be tokenized, and we will remove some stop words and non-alphanumeric tokens. We will lemmatization. Lemmatization is also a crucial part of NLP. And could you please shortly elaborate on that, ChatGPT?
Lemmatization reduces words to their base or root form, enhancing consistency and reducing dimensionality in NLP tasks. For example, running becomes run. This helps models better understand context by treating different forms of a word as the same entity, improving text analysis accuracy.
Thank you for that. And then we're rejoining tokens into a process string. Could you also elaborate on that?
Certainly. After tokenization and processing, like removing stop words and lemmatization, rejoining tokens back into a single string creates a cleaned up version of the text. This process string can then be used for further NLP tasks or modeling, making the data more consistent and manageable.
Okay, that's a great point. So here we'll convert to lower text, we'll remove the URLs, HTTP, and then we will tokenize, we will filter, remove stop words, punctuation, non-alpha tokens. What are non-alpha tokens?
Non-alpha tokens are characters that aren't alphabetic, like numbers, punctuation, or special symbols. Removing them helps focus on meaningful words and reduces noise in the text data.
Okay, so apply the preprocessing function here. So we have created a function here, simple preprocess. So we will apply that, and we will tokenize and pad sequence, maximum vocabulary size, maximum sequence links, so vocabulary, sequence, and then we will use the tokenizer here out of vocabulary token, and we will apply that to the we'll just use these in that here, and then we will so this is tokenized num words, max words, and then OOV token. Could you elaborate on that, ChatGPT? Okay, so here is our result here from preprocessing, and we have
the num words parameter in the tokenizer limits the vocabulary size, keeping only the most frequent words. The OOV token is used to represent out of vocabulary words, which are words not seen during training. This helps manage
Okay, thank you for that. Okay, so we will here
the preprocessed data is now ready for further analysis or modeling.
Yeah, so we get here preprocessed data headlines here, and we have the rows here, and we have 2 columns here.
You're welcome.
So the different columns. So when we have tokenized here, so that's they have some numbers here based on the. Okay, so we'll final dataset preparation. So we will combine the PCA transform numeric features with text features, and define our target for training and testing. So we will just here we will take the our final numeric features from PCA we had above, and we will have the PCA here. Oh no, sorry, this one. Yeah. So we have from that one the numerical data. Not the numerical data, but the parametric numerical data,
and the target variable,
and the headline data here. So now we can move that into a new data set here, or new and we will have the target value here. So yeah, what are you saying, ChatGPT?
Exactly. Now we can proceed with modeling using these features.
Yeah, exactly. So now we'll split it into train test, which is an important step here of the machine learning, that we have a training data set, and then we will have some test data set that we can benchmark against to see what if we are going the right direction. And we will split the index here.
Combining the PCA transform features with the tokenized text features will give you a comprehensive data set for modeling.
Yeah, and we split the training and test samples here, and then we will save the preprocessed data. So we will just into new arrays or new data frames, and then we will call the preprocessed data, and then we will pickle it, and then we will go on to model building. So change the slide.